Hello, my name is Sven. I'm a geologist at ELIS, and I'm going to introduce you today to one of the new features of PaleoScan 2019, which is for today the GeoCellular model, or the GeoCellularGrid. So let's get started. So the GeoCellularGrid in PaleoScan 2019 is a part of the add-on module, the Advanced Interpretation. So it's following the tool of the sequence stratigraphy. And so the GeoCellularGrid is built from the sequence stratigraphy. So you'll have to activate your Advanced Interpretation extension in PaleoScan. So just to remind you how PaleoScan works, in PaleoScan we are creating a relative geological time model, which we name RGT model. This is the image you can see here to the left. And this model is created, it's made of a continuous series of color vertically, and the series of value which is behind it is infinite, so that we can create a surface, a boundary at any point of the RGT model. From this RGT model, we are going to use the Strativiewer to create a sequence stratigraphy made of different boundaries in this tool. So depending on if you're considering creating a sequence stratigraphy based on the sequence of system tracks in the geology, or in terms of lithology, you would consider your layers as simple layers or system tracts. So if you've got some well data, including some top data, as is the case in this central image, you can create on this sequence stratigraphy tool the layers that you want to build based on the position of the well tops. So this is the example that we've used here. So the geometry of each boundary would be made according to the geometry of the RGT model. And from these main geometries, so from the building of these layers in the Strativiewer, we're going to be able to set a gridding with a specific vertical resolution and specific key boundaries. So this is what you can see here on the image to the right. So moving forward, here is an example of application of building of a GeoCellularGrid. So we are here in the Strativiewer. So in this case, we are using here in the ribbon, you can notice we are using a reference geomodel to constrain the geometry of each boundaries we're going to build. And we're using the seismic for the background signal, and just get to know where we are building our boundaries. And in this example, we are also using some well data with some well tops to define the position of our boundaries in the seismic interval. So just for the record, this example has been made with the block F03 offshore Netherlands. So here, some key boundaries are being built to define some specific layers or system tracts, and each boundary is following the geometry of the RGT model in the background. So once we are having this sequence of layers with a defined geometry, we can define some sub-geometry inside the layers, so some inner geometries inside the layers, and detail a precise resolution by building a sublayering. And this is what we are going to see through this framing here. So the Edit tab gives access to a specific table here to the left. And in this table you can see that each layer has a name, so in this case no name has been assigned to the layers. And there is a specific column for the method, which is describing the inner geometry, so by default it's isoproportional, so the geometry will be built from the top and the bottom key boundaries of each layer, with a distribution of the sublayering in the layer. And we can input a specific number of layers in there. So each inner geometry of each layer can be defined by three basic geometry, which will be parallel to top, so the inner geometry will be parallel to the top layer, parallel to the bottom, and isoproportional, as I was explaining just before. And the vertical resolution can also be controlled in each of the layers, and so a user can input any number of layers in each respective layer of the sequence. So here is an example of sequence stratigraphic building in the aim of creating a geocellular grid in the case of an arbitrary line along the wells. So it's possible in PaleoScan to create arbitrary lines along the wells instead of just playing with the Strativiewer and scrolling through the 3D seismic. And so the well markers will help us to determine the position of each key boundaries that we're going to build. So when we're using some specific settings in each layers with specific inner geometries, here is what we can get. So in this case, we have assigned some precise geometries inside the main layers with a specific resolution. So once we are happy with the setting of the future geocellular grid from the sequence stratigraphy, we're moving forward, and here is the interface of creation of the geocellular grid itself, or the geocellular model. And we still have to the left the sequence, the Strativiewer, just if we want to modify the geometry of the layers and the inner geometry. And to the right, we get the interface of creation of the grid. So in this grid, we can in particular assign a specific lateral resolution to the grid. So here in terms of size or in terms of bins, so in X line and in line. And we can also, if we're having some, include a fault set into the future grid. So the fault set will be included into the geocellular grid as a stair-step fault, so that we can create some lateral structural discontinuity into the model. So here is a preview of what we are having in terms of future geocellular grid based on the sequence that we've been doing before. And here it's based on a lateral resolution of 10 bins laterally in X line and in line. And here is a difference with a special resolution of 20 bins. So if I'm moving back and forward, here is the difference in between the two. So now is the results of the geocellular grid when we've created it. So what we can see here is that we are well respecting the geometry that we defined through the Strativiewer before. So we're still having in between the main layers the geometry of the RGT model, and in between, in each layer, we still have a synthetic geometry such as we defined in the Strati tool. So just a bit of zoom in. So here, for example, you can clearly see that the geometry of the RGT model, that is itself constrained by our interpretation of the seismic, is well preserved. So this way we're actually preserving the accuracy of our interpretation into the geocellular grid. So here, if we are having some well data available with some specific logs, we can thereafter precisely populate the grid with some specific properties, which is the goal of the modeling. So for example here, we've been populating the geocellular grid with a specific property based on the log data. So I must say at this point that we are starting to populate the properties with the log data. And in PaleoScan, we're using the tool of the property modeling to propagate the data in a volume. And from this volume with a specific data, it can be, for example, the thinning, the RMS amplitude, the gamma ray, we're using this specific volume to populate the grid with this property. And we're going to see this in the demo session that is following just after. So prior to the demo session, I'm just going to summarize the main workflow of this geocellular grid building. So everything starts with the RGT model, which defines the geometry of the model in PaleoScan. So from that, we can open a Strativiewer. We are using the model to define the geometry of the future grid. We are vertically defining the geometry and the resolution that we want in each of the layers of the sequence that we are building. We are defining the lateral resolution of the grid. And then if we want, we can include the faults as stair-step faults into the future geocellular model. Eventually, when the grid is built, we can propagate some property with the property modeling into the grid. And of course, the grid itself can be exported in the Geocel format, which is a common format for various softwares. So let's go for the live demo. So now we are in the PaleoScan 2019 interface, and we're going to go through the live demo. So the first thing you're going to have to do would be to activate the Advanced Interpretation add-on to build the GeoCellular model. So the first thing you have to do after having activated the add-on would be to create a new sequence. So we are going to go in the GeoCellular model module, and we're going to click on New Strati Viewer. So on this Strati Viewer, I'm going to have to select the RGT model of reference. So if you have a GeoModel without any faults, that's better because you can preserve the lateral continuity of your model. Else, that's fine, you can still select something else. I'm going to select an attribute for the background display, so in this case the seismic. I'm dragging and dropping the item in the corresponding field. I'm going to enlarge the interface temporarily just to see what we are doing. So once I'm having the seismic display in the background, I'm going to create a new sequence to create some boundaries. So just for the geological context in there, so here I've got the limits with the basement, which is for the basement made of some Cretaceous with some Paleocene. On top of it, we've got a succession of siliciclastic sediments, both marine and both terrestrial, and we've got from this level here some Miocene interval with some giant foresets until this erosional surface here, and from here starts the Pliocene, again with some tiny giant foresets over here up to here with another erosional unconformity. So I'm going to play with this Miocene-Pliocene interval to create my sequence. I'm going to start with the erosional unconformity between the Miocene and the Pliocene. Okay, creating one main boundary and a second one. As soon as I'm creating two main boundaries, PaleoScan is going to create a layer, first layer of my sequence, and so on. So I'm going to encompass the tiny giant foreset interval here up towards this unconformity here, and I'm going to create a few boundaries in the giant foreset of the Miocene down there. So let's say, for example, here towards the bright reflector. Another sequence may be here, for example, one here, a boundary here, and one last boundary down there. Okay, so now I've got 7 different layers in my sequence. Okay, and I can check at the geometry of my sequence, scrolling through the seismic if I need to. I could also choose to switch to the EX-line dimension to check at the consistency of the geometry of my sequence. No, not what I can do. I can also select one particular boundary and move it up or down, playing with the up or down arrows from my keyboard. One thing that I didn't explain during the slideshow with PowerPoint is that you can create some truncations if you want to respect the geometry of a specific stratigraphic interval. So, for example, I'm going to take this green layer in the middle here, and I would like to truncate it over here because, geologically speaking, it's not really existent anymore in this interval here to the left. So to do so, I'm going to jump to the Sequence Stratigraphy toolbar and play with a specific tool, which is the truncation mode, to apply after a certain threshold, so threshold in terms of thickness, a distortion of either the top or the bottom boundary towards the other one to cut it and create a truncation. So in this case, I would like to cut the bottom boundary on the top one, which is the erosional unconformity. So in this case, I would tell PaleoScan to cut the bottom boundary on the upper one, which is the reference one, so the erosional unconformity. If I want to visualize the result of my truncation, I would like to activate the specific option here, truncation, and see the result of my truncation. So just for the example, I will create only one truncation here. I could create more. Now I'm satisfied with the geometry of my main layers in my sequence, so I'm going to apply an inner geometry to each of the layers with a specific inner resolution. To do so, I'm going to double click on each of the layers, go in the Properties panel here, and select a specific inner geometry. So for this top layer here, I'm going to use geometry parallel to bottom, assign, for example, 7 different sublayers in the main layer. So here they are, and so on. So this one I'm going to leave it to isoproportional, maybe 4 layers in there. For this one here, isoproportional as well. Okay, 3 layers, and I can go by any point on my parameters. For example, if I want to increase the number of layers in there, I can just do this. For this yellow layer in the middle, I'm going to apply a specific geometry that will be parallel to bottom, because I want to mimic the synthetic geometry of the seismic in this layer, so parallel to bottom, and let's say I want to put 10 different layers in there, 10 sub-layers. I'm going to skip this brownish layer on purpose here. I'm going to the green one, which I will determine in terms of geometry as being parallel to top. I'm going to put, let's say, for example, 8 sub-layers in there, and ending with the last one. Let's say I want only 3 sub-layers in there with isoproportional geometry. So now these synthetic sub-geometries, inner geometries, are quite convenient if you want to create a geocellular model, which will be quite synthetic as well, and in particular if you've got a seismic with some low amplitude seismic signal, or as well some noise in the seismic, so that your geometry would still be consistent with the one of the seismic. Now if you need to have a more accurate geometry, would still respect the RGT model that you've been created, provided that this one is accurate, you'd have to create some more key boundaries to split, for example, this main layer into several smaller main layers. I'm just going to create 3 smaller main layers. Okay, and these smaller main layers would still respect the geometry of the geomodel. Now that I'm satisfied with the vertical resolution and the geometries of each of my layers, I will create the GeoCellularGrid. So to do so, I'd have to go back on the GeoCellular model module toolbar. I'm going to reduce the Strativiewer window, and I'm going to use this option over here, the GeoCellular model from Strati. When I'm clicking on this, the interface of creation of the GeoCellularGrid would appear to the right of this first Strativiewer interface, and I will be able to adjust several parameters. First, I can add a full set to be included in my future model. So for example, I'm going to take this full set, I'm going to drag and drop it, and this full set will be included in terms of structural discontinuities as stair-step faults. So let's say I want to adapt the lateral resolution of the grid, so I'm going to put 20 bins for the X-line and the N-lines, and I'm going to have my preview. If I want to reduce the size laterally of my geocellular grid, I can just play with these white anchor points and modify the spacing of my future grid. So vertically, the geocellular grid would be limited by the sequence I've been created here to the left. So now I could click on OK, and to be a bit faster and save some time, I'm just going to go into one of my own geocellular grid, which are already ready in my project browser. I'm just going to reduce this window here, going to the GeoCellular tab of my project browser, and for example, I'm going to open this output of GeoCellularGrid. So if I'm displaying the 3D window, here is the output of the GeoCellularGrid I've been created. So the geometry of this one is pretty much similar to the one I was creating in the sequence Strativiewer before. And we can see that the geometry of the main, of the key boundaries is respecting the geometry of the geomodel. So now if I want to display the vertical limits in between the cells, I just have to select this model here and go in the properties to activate this option here, Show Grid. And you'd notice that on the right corner of this GeoCellular grid, I've got some cells that are corresponding to no data in the seismic survey. So if I want to hide these cells in particular, I'd have to go back in the properties and deactivate this specific option here, Show Inactive Cells. And here, only the cells corresponding to the seismic are being displayed. Now if I want to scroll through the GeoCellular grid and visualize the geometry of it, I just have to select by double-clicking the top of my cellular grid and scroll through it. So as if I were scrolling for a horizon stack. So scrolling through it, PaleoScan will remove every layer of the GeoCellular grid, and I'm going to go through this until the erosional inconformity between the Miocene and the Pliocene, to be able to visualize here the top laps truncated on the inconformity. Now if I've got some well data available for my project, which is for example my case here, I'm going to my 3D object list, I've got some gamma ray information that are available. Okay, they're here. I'm just going to deactivate the GeoCellular grid for a moment, just to show you my gamma ray data. I can use the property modeling tool of PaleoScan to propagate the log data throughout a specific volume, which will be following the geometry of the RGT model. So the specific module of property modeling is here. The option is now great, but through this tool I can create a new volume with some specific property. So for instance, in this project we can find a gamma ray volume here. Once I'm getting this type of volume, I can populate my model grid, my cellular grid, with the property. So now in my project I already have a GeoCellular grid which is populated with the gamma ray information. I'm going to display it. So clicking on the gamma ray information here, and because by default the color scale may not be adapted, I will change it for the color bar manager and replace it by something which is more consistent. So for example, the channel color bar here. And I'm going to invert it, as we're more used to see some yellow colors for low values of gamma ray. I can adapt the contrast and the distribution of this color scale. And again, I can just scroll through my model. So I'm about to be done with this presentation. By the way, you'll notice that the faults have been included here as stair-step faults in the model. So you could populate your model with any type of properties that you have available in your PaleoScan project. You could also export the specific grid. And I would like to thank you for your attention and your interest into these new features of PaleoScan 2019. I would like to encourage you to contact our support if you're in the process of creating a grid, if you want more information.